Okay, welcome to my laboratory. This is a little bit of an exploration of the so-called supernova mode. That, that right there, whoa, that is an ammeter hooked to the battery input. And over here's our test receiver. And there's the thing. And then down here I have a little ruler so I can tell how far away we are from things, and right now I've got the two coils 15 centimeters apart. Okay, and I'll switch on here. Okay, so 15 centimeters apart, and this light is glowing there, and it says 1.28 amps. Right? Can you read that ammeter all right? Okay, so what I'm going to do is just move closer and closer, and I want you to pay attention to the brightness of the bulb. Oops, there we go. It just shifted into what we call supernova mode. I actually don't want it to do that this time. Now it's staying not in supernova mode, and you can see that the current, I hope you can see that, 2.15, the current goes up as I get closer and closer to the transmitting loop until finally when I'm as close as I can get, which is 2.5 centimeters, I'm at 3.21 or 3.2 amps. And as I go back, the current goes down 1.8, 1.7, 1.6, 1.5, 1.4, 1.3, 1.2, until 15 centimeters now. Oh, now we're down to 1.05 amps. That's the dog's okay. Sorry about the pause, I just had to let the dog in. Okay, so there we have an increasing brightness as we get closer, and the current goes up, and we reach a maximum value at maximum closeness, something about 3.23 amps, and then decreasing as we go back. Alright? All well and good. And at 15 centimeters we're back to about 1.06 or so. Okay, now where's my probe receiver? Oh, there's so much detail in here, I keep losing things. I haven't, this is another receiver. Where did it go? Oh, okay, here we go. Here's my other receiver. This is the probe receiver. So now what I'm going to do is just put this receiver in between the two, and just pay attention to the current. Okay. As you might expect, the current goes up when you're driving two bulbs. 1.5, and then boom, there's the supernova mode. Now we've got 4.23 amps on the meter. Okay, and then back. All right, boom, and you can see the first receiver's bulb brightens, and then right there at that supernova transition right there, it sort of starts dimming again. Right. Okay. Well, now I'm going to move this receiver in a little bit more to about. Let's put it to 10 centimeters, and that gives us a base current of 1.7 amps. You see that all right? And then here comes our probe receiver again, in there. Boom, there's supernova mode, except this time the test receiver stayed in supernova mode too. Now I want you to pay attention to the current over here, okay? So it says 3.1, 3.2 amps. I'm going to move it closer. 3.1, 3.0, 2.9, 2.8, 2.7, 2.0, 2.5, 2.4, 2.3 amps at as close as it'll get. Now we'll move back 2.4, 2.5, 2.8, 2.9, 3, 3.2, boom, and then right there at about 7 centimeters it shifted back out of supernova mode. Here we move in, and we get that same fall off with distance like we normally expect to get. Right? But if I put the test receiver in, the probe receiver, until we get that supernova transition, Now we've got, oops, I think my battery's gone dead. Boom. There's supernova. Here we go. There's a supernova on the test receiver. And if it'll just stay in there, sometimes I can get it to go from this side. There we go. Alright, what I'm trying to show here is that when it's in this mode, the current actually increases as you get further away. 3.1. Oops. Okay, there it's 2.6, 2.7, 2.8, 2.9, 3.0, 3.1, and there we flick back and it drops down to 1.3 at about 6 centimeters. Okay, so this supernova resonance mode is all very, very interesting, I think. Of course, it works better when you have a fully charged battery. And here I can get up to about almost 6 amps input with both of the bulbs in the supernova mode there. See how there's no fall off with distance when it's in this mode? This one over here stays at the same brightness no matter what the distance is. And here we get up to like 4.5, 4.4 amps, 4.3, 4.2, 4.8, 3.0, 3.9, 4.8, 4.4, 4.5, 4.6. So this supernova mode, whatever it indicates, is actually pretty interesting because it seems to indicate that there's a direct, not an inverse square fall off, not a broadcast connection, but some kind of a sort of a direct inductive connection between the transmitter and the receiver. And the further away you get, it takes a little bit more power to maintain that connection. So the power actually goes up as you get a little bit further away, 4.3, 4.4, like that. Okay, so exploring the supernova mode. Whoops, there went my ruler. Thanks for watching.